Hello class, today what we're going to talk about is the effect of dimensional changes on perimeter area. What this is talking about is what happens when we double the length of one side or triple the length of another side. All right, what does that do to perimeter? What does it do to area? So here we're going to look at problem A. We're going to double the height of the triangle. So remember, this is going to be the height, this is going to be the base. It doesn't always that way, but it is for this. So, all right. So we're going to double the height from 4 to 8. Easy way to see this is figure out the perimeter from the old triangle, figure out perimeter for the new triangle. Figure out area for the old triangle, figure out area for the new triangle, see what happened. How did it change? All right. So we have dimensions for the old triangle before the change, dimensions after the change. So we double the height going from 4 to 8. It's a triangle, so we perimeter, add up all the sides. So we have the 3, we have the 4, we have to get this hypotenuse here. We're going to do Pythagorean theorem. And this is a Pythagorean triple, 3, 4, 5. So that comes out to 5. 9 plus 16 is 25. So it is 5. So that adds up to 12. Over here, 3 plus 8, and we do Pythagorean theorem. Not a Pythagorean triple. This is the square root of 73, which is ugly. So it was 12 centimeters, now it's 11 plus the square root of 73 centimeters, whatever that is, right? We'll have to stick it in a calculator to find out. But first, let's go ahead and fill out the area. Triangle is 1/2 base times height, so 1/2 times 3 times 4 equals 6. 1/2 base times height, so 1/2 times 3 times 8, which is 12. So, doubling the height increased our perimeter by, we subtract this, let's see, 11 plus 7 square root of 73 minus 12 is approximately 7.54 centimeters. Increase the area, well, it went from 6 to 12, so that it doubled the area, right? Because 12 is 2 times 6. 12 over 6 is 2. That doubles the area. So that's nice. B. This time we're going to multiply the length by 1/3. And remember, the length on a rectangle is the long side. Not necessarily the one that's going down here. It could be going up there, but it's the longer side. Short side's the width, long side's the length. All right? So, length is 12, width is 5. We're going to multiply it by 1/3. So 1/3 of 12 is 4. All right? So now it's 4 and 5. Perimeter, it's a rectangle, so it's 2 times length times 2 times the width. Plug in the numbers that we have up here, 4 and 5, 12 and 5, and we end up with a perimeter of 34 feet and a perimeter of 18 feet. And if there's some pattern there, I can't see it. Area, let's take a look at area. Length times width, so 12 times 5 is 60, length times width, 4 times 5 is 20. That, we got something going. So multiply the length by 1/3, decrease the perimeter by, well, let's see, it was 34 minus 18, so it decreased it by 16 feet. And it decreased the area by, well, it was 60 and now it's 20. That's 1/3 of what it was beginning with, right? So, not so much a pattern with perimeter, but with area, you'll notice we doubled the height, it doubled the area. We got 1/3 of the height, it ended us up with 1/3 of the area. So whatever you multiply one of your sides by, that's what's going to happen to your area. Is that going to happen to the perimeter? No, but it will happen to the area. For perimeter, so you're going to have to work this out. So I want you to work this out. Describe how multiplying the width by 1/2 affects the perimeter and area of this rectangle. Pause the video, then come back and check your work. All right, let's see how you did. Should have had an answer that the perimeter decreased by 8 feet and the area decreased by a factor of 1/2. Notice 1/2, 1/2, right? And if you didn't get that, let's work it out, see what went wrong. Here it is. Remember, the length is the longer of the two sides, so the 10. The width is the shorter of the two sides. So when we multiply the width by 1/2, that's the 8 that's getting cut in half, down to 4. If you took 10 and cut that in half down to 5, you got different answers because that's not the length, that's the not the width, that's the length, and we want the width. All right. So 8 plus 10 is 18 times 2 is 36 for the old perimeter. 10 plus 4 is 14 times 2 is 28 for the new perimeter. Area, 10 times 8 is 80, 10 times 4 is 40. So you see half the area, but not half the perimeter. Perimeter, you'd have to work it out. No shortcuts there. Okay, so what happens if we do stuff to both dimensions, both length and width, base and height? All right, so on A, we're doubling the length, we're tripling the width. For the rectangle here, so here's our setting up the little table. It was 7 by 6, double the 7 to 14, triple the 6 to 18. Plug this into our perimeter formulas, and we see perimeter goes from being 26 meters to now it's 64 meters. Again, not much of a pattern there. Area, length times width, length times width. Plug in the numbers that we have up here, and area goes from being 42 meters squared to being 252 meters squared. And I'll admit, I don't see much there either. However, we go ahead and subtract this out, and we see perimeter increased but has a change of 38 meters. Area, however, is increased by a factor of, let's see, new over old. Right? That's a factor of 6. Where did that 6 come from? We'll take a look at that. All right, problem B, we're going to multiply the base by 1/2, going to double the height. So set up our table here. Base was 6, height was 8, half the base is 3, double the height is 16. Perimeter, going to have to do that Pythagorean theorem again. At least they were very nice and gave us right triangles so we could find the third side without having to do law of sines or cosines or something. All right. So this is, again, a Pythagorean triple, 6, 8, 10, adds up to 24. This is not, so we end up with square root of 256, which is lovely. All right, area, 1/2 base times height, or base times height divided by 2, however you like it. 1/2 times 6 times 8 is 24. 1/2 times 3 times 16 is 24. Hey, that didn't change. Why is that? Let's take a look. So perimeter, we take old minus new. We get a change of 11.28 inches. All right. Area didn't change. Let's take a look at our factors here. Notice we doubled the length, tripled the width. So the length was times 2, the width was times 3. 2 times 3 is 6. And notice our factor here, 6. Up here, we took half the base and then the height times 2. Well, times 1/2 times 2, half times 2, half of 2 is 1. So times 1, and when you multiply times 1, nothing changes. So there it is. So if you, whatever you change this by, you multiply your area by that. Multiply by 2, then multiply by 3. Multiply by 1/2, then multiply by 2. And that gives you your new area. So area is nice and easy. Perimeter, again, no shortcuts. Sorry. Again, I want you to work these out on your own. Pause the video, then come back and check your answers. So pause the video and go. All right, let's see how you did. Should have had an answer on number 2. Multiplying the width by, or the length by 4 and the width by 1/2 should give you an answer of the perimeter increasing by 89 meters and the area increasing by a factor of 2. On the triangle, double the base, triple the height, should have increased the perimeter by approximately 37.3 feet and increase the area by a factor of 6. So let's take a look at these if you got those wrong. Here's the tables. Length and width. Remember, the length is the long one, width is the short one. So we multiply 16 by 4, multiply 7 by 1/2, and we get 30.5. Plug those into our perimeter formulas. We have 46 for the original, 135 for the new one, just substituting those in. Subtract them out, and you get 89. For the area, 16 times 7, 64 times 3.5. But if you'll notice, again, times 4 times 1/2, half of 4 is 2. So it gets doubled. For number 3, here's a little table there. Original, 12 and 5. New, double the base, triple the height. So 12 times 2 is 24. Height, 5 times 3 is 15. This is a Pythagorean triple again. 5, 12, and 13 adds up to 30. This is not a Pythagorean triple, so that doesn't work. So we're going to have to do Pythagorean theorem to figure out this is square root of 801, which simplifies as 3 square roots of 89. All right, that's where that comes from. And then you subtract those, and we end up with this, which is lovely. All right, for the area, we have 1/2 times 5 times 12, 1/2 base times height, is 30. And after 1/2 24 times 15, 1/2 base times height is 180. And so we end up with a factor of 6. Notice times 2 for doubling, times 3. 2 times 3 is 6. All right. Now, we are going to get to one shortcut for perimeter and also for area, so it's nice. If you multiply all the linear dimensions, both the length and the width, the base and the height, by the same positive number, which we will call k, our scale factor, then the perimeter gets multiplied by k, all right, whatever our scale factor is. The area does not get multiplied by k. The area gets multiplied by k squared because it gets multiplied by k once for the length and once for the width. All right, once for the base, once for the height. So it's that number twice, so k squared. All right, notice the important thing here is you have to multiply all the linear dimensions, both the length and the width, by that same k. If you multiply them by different things, stuff doesn't work like this. It's no good. You got to work it out by hand, the long way. So here we go. Let's take a look at this. We are going to double all the linear dimensions. We're going to double the height. We're going to double the base. We're going to double the other side here. All right. What happens to the area and the perimeter of the parallelogram? Well, honestly, we just care about base and height. Right? So we have the base. We have our height. Base, height. For perimeter, we add up all the sides. So we do care about this one. But for area, we just care about these two. So we have 2 times 10 plus 2 times 5, which is 30. And we could take this and add all of this up, but we don't need to. It's just going to take the 30. We doubled everything. 30 times 2, 60. And if you don't believe me, well, this would be 20. This would be 10. 20 plus 10 is 30 times 2 for the other side is 60. Look at that. Area. Original area is 4 times 10, 40 meters squared. New area, well, we're doubling it. So k is 2, k squared is 4, so 4 times 40 is 160. We've already seen how that works. We're multiplying the 10 by 2, so that doubles it. We're multiplying the 4 by 2, so that doubles it again. So double times doubles is times 4. All right? And then we subtract these. We can see how that works. But doubling it doubles the perimeter. Doubling it increases the area by a factor of 4. Multiplies it by 4. So I want you to do this one here, work it out, pause the video, come back, see how you did. Check your answers. All right, let's see how you did. You paused it, you worked it out, and hopefully you said that the perimeter is going to decrease by a factor of 1/2 because we're multiplying everything by 1/2, and the area is going to decrease by a factor of 1/4 because we're multiplying everything by 1/4. And so its area, it's k squared. 1/2 times 1/2, half of a half is 1/4. Right? If that's not what you get, or you don't believe me, that's what you should have had. K is half. K squared is 1/4. So this is for perimeter. That's for area. Or I went ahead and worked it out the long way here. We did have a base of 14 and a height of 12. Both of those are getting cut in half. So we now have a base of 4 and a height of 6. This is not a Pythagorean triple, unfortunately. So perimeter works out as 26 plus 2 times the square root of 85. After the change, we end up with 13 plus 1 square root of 85. Notice half of 26, half the square root. It's half. The perimeter was halved. For the area was 14 and 12, so 1/2 14 times 12. It's now 7 and 6, 1/2 7 and 6. So 84, 21, and if you'll notice, 21 is 1/4 of 84. So you can see this does work. All right. So that is how changing the dimensions of a two-dimensional figure will alter the perimeter and the area. Unless everything is being changed by the same scale factor, for perimeter, you're going to have to work it out. No shortcuts. Sorry. Area, you just multiply the area by the scale factor that you happen to the base and the scale factor for the height, and it's good. I hope that helps. I'll see you next time.